Welcome to this video mini lesson introduction to independent samples t-test. Here are our beloved beads again, representing our population. Now we've just been studying a single samples t-test, and the single samples t-test, if you recall, takes a sample and then runs a statistical analysis to determine whether that sample and the population as a whole are statistically different from one another in a specific way. Now, with our independent samples t-test, instead, what we are doing is we're taking two different samples from the population, and we're running a statistical analysis to determine whether these two samples are statistically significantly different from one another. So let's talk a little bit about what this looks like and what this means. So the independent samples t-test is used to determine whether two samples that are not dependent upon one another are statistically significantly different from one another. And there are four assumptions that must be met in order to conduct an independent samples t-test. The first of which is that the samples are indeed independent of one another, that there are no what are called built-in linkages. So if you consider an example here, let's say that these beads represent all students in the state of North Carolina, and I want to look at whether a sample of African American students and a sample of Latino students are statistically significantly different from one another in some way. Or what I might want to do is take a sample of students and have them utilize Saxon math curriculum. And I take another sample of students, and they're my control group. They don't get this quote-unquote sort of new curriculum of Saxon math, and then I compare the two together, say, for example, on math achievement. So that would be another example of independent samples. There's really no linkage between these students who have been randomly selected for the treatment group and these students who have been randomly selected for the control group. Now, let's do an example of a dependent sample. So a dependent sample is going to be structurally linked in some way. Like, for example, using the same people twice in like a pre-post sort of situation. So if I took this sample of people and I do pretest on them, and then I run them through a program that's supposed to prevent the development of substance abuse issues for students who are at risk of developing those, and then I conduct a pretest later, perhaps 2 years later, to see to what extent this treatment program, or this, prevention program has helped to keep these students from developing substance abuse issues. So my my sample is the same for both analyses, both the pretest and the post-test. So this is obviously a dependent sample, because my sample for the post-test is absolutely dependent upon who took the pretest. So now let's talk about what are called matched samples. So let's say, for example, that I wanted to study, let's see here, the effects of playing sports on female students' self-concepts. So what I might do is get myself a population of female students, and I have them participate in some sort of organized sporting opportunity. And then I have another sample of female students of like age and perhaps similar to my treatment sample in other ways as well. For example, socioeconomic background or whatever. And so both my treatment sample of female students, and then I have my control sample of female students who don't go through that same organized athletic opportunity. Let's say it's field hockey or lacrosse or whatever. And then I compare the results of the two on a test of self-concept or self-confidence or whatever. These are what are called matched samples. Because I'm focusing on gender as a variable, I need to make sure that both of my samples are of the same gender, and they may have similar structural similarities as well, such as, like I said, socioeconomic background or whatever. So these are what are called matched samples, because I can't just randomly select from my population in order to put together these two samples. They are linked in the sense that they're both female, they're both of the similar age, etc., etc., etc. So those are what are referred to as matched samples. If I were doing a study of schools, I might match a population from urban and a population from another urban population in order to compare and contrast a program that's supposed to make it more likely that urban students will go to college. So again, these would have to be what are called matched samples, because I need an urban population and another, urban population, I'm getting a little too excited here, for both my treatment and my control groups, as opposed to just randomly selecting for both, okay? So this is what we mean by independent samples, no built-in linkages. So then also the second assumption is that the dependent variable is an interval variable. So as opposed to a categorical variable, for example, but it has to be an equal interval variable in order to have the independent t-test be appropriate. Also, the samples have to be normally distributed. And this is the same assumption for some of our other analyses as well. But you actually have to make sure that you test for whether it is for whether the samples are normally distributed. So you need to use the descriptive statistical procedures that we've talked about in the past. And then also you have to determine whether the samples have equal variance or variability. And in order to do that, you have to conduct a test of homogeneity, and we'll be learning about that. But if the samples aren't homogeneous, then you cannot conduct an independent samples t-test, and we'll be talking more about that. And as always, if you have questions, please let me know. Thank you.